Here we have our standard sine curve, and the amplitude here is 1, and we see that we complete one full cycle of sine between 0 and 2 pi. So when we talk about the period of our sine and cosine functions, we are talking about the distance or the length required to complete one full cycle of sine, so one of those basic shapes. And we see right now if b is 1, so basically y equals sine x, the standard sine curve, if b is 1, then the cycle repeats itself every 2 pi units. So the period of our standard sine wave is 2 pi. Now what if we change b to be 2? So notice what happens to the graph when b becomes positive 2. So if b becomes 2, let's zoom in a little bit. How many full cycles do we actually complete between 0 and 2 pi? So we actually see that we completed one full cycle between 0 and pi, and then the cycle repeats itself again between pi and 2 pi. So the period now of the sine function would be pi units. If b is 2, then the period becomes pi units. So every pi units, I'm going to zoom out a little bit here. Every pi unit, so from 0 to pi, and then pi to 2 pi, 2 pi to 3 pi, every pi units, the sine curve now repeats itself. If b is 3, then the sine wave will complete 3 full cycles in between 0 and 2 pi. If b is 4, then we complete 4 full cycles of sine between 0 and 2 pi. And what is the period of the sine wave here? So let's look closely. We complete one full cycle between 0 and pi over 2. So that must mean the period of this sine wave is pi over 2 units. So every pi over 2 units, we go from start to finish of that sine wave, that basic shape. So if b is 4, then our period was pi over 2. So let's see what happens when we go smaller, if we make b to be 0.5 or 1/2. That means we complete half a cycle of sine in between 0 and 2 pi. So we can see that we only get the part that starts at 0, goes up, and then comes back down to the x-axis. In order to complete one full cycle, we would actually have to go all the way to 4 pi. So if b is 1/2, the period of the function, the length required to complete one full cycle will double. It will become 4 pi. So every 4 pi units, we see a complete cycle of sine. So let's zoom out a little bit more. So from 0 to 4 pi, one full cycle. From 4 pi to 8 pi, one full cycle. Every 4 pi units in both directions, one full cycle of sine is complete. We can do the same thing with our cosine function. So I'm going to hide the sine graph there. I'm going to highlight the cosine function. Zoom in here. Let's change b back to positive 1. And we see that this is our standard cosine wave. So it starts high, comes down to the x-axis, goes low, comes back up, and finishes at 2 pi. So if we zoom out a little bit, we see that every 2 pi units, cosine repeats itself. Let's change the b, let's multiply the inside of the function by 2. So once again, we see 2 full cycles of cosine are completed between 0 and 2 pi, and the period now would be pi units. If we change b to be 4, now the period to complete one full cycle would be pi over 2 units. So every pi over 2 units, cosine repeats itself. What if we change it? Let's go all the way up to 6. So we get 6 full cycles of cosine between 0 and 2 pi. And let's go all the way up to 8. So we complete 8 full cycles of cosine between 0 and 2 pi. And the period of the function, let's look closely to see a full cycle of cosine starts high, goes back to the x-axis, goes low, back to the x-axis, and then back high. So the period of this cosine function, if b is 8, the period would be pi over 4 units. So every pi over 4 units, the cosine wave will repeat itself.